CMP instruction. CMP instruction is used for comparing two operands. So this is the syntax: compare destination comma source. One example is CMP BX comma CX. So we have to check whether BX and CX are equal, or BX is greater than CX, or BX is less than CX. So let us look how this is done. So first, CMP instruction will subtract the source operand from destination operand. So in this example, the compare operation will do CX minus BX, and based upon the result, the flags will be affected. This result is not stored anywhere. So how the flags will be affected? If both these operands are equal, 0 flag is equal to 1. 0 flag will be set. Now if both operands are not equal, there are two cases. The source can be greater than destination, or destination can be greater than source. If source is greater than destination, that is, if CX is greater than BX, carry flag will be set. Else, if destination is greater than source, that is, BX is greater than CX, if that is the case, carry flag will be 0. So by looking at 0 flag and the value of carry flag, we can do the comparison operation in 8086. So this operation is very important, the CMP instruction. (8086) program to sort numbers in ascending order. So we have to sort some numbers. Sorting means arranging the numbers, given numbers, in some order. So ascending order means smallest first and largest in the last position. So let us look at the program. This is the data segment. String 1 define byte. These are some example values. We have to sort these 5 numbers. Code segment, the assume statement, start initialization of the DS register. Now we are initializing the CH register with 04H, and this is the label 2. Move CL, 04H. So this CL register is mainly used for iterations. Now LEA SI, string 1. So the address of string 1 will be copied to the SI register. LEA instruction means load effective address. That is the meaning of that instruction. So the address of string 1, whatever be the address of string 1 in the data segment, that address will be coming to the SI register. Now label 1, move AL, SI. So the first value will come to AL register. So 99H will be in AL register. Then move BL, SI plus 1. So this is the next address. SI is the address of the first element or the list of elements. SI plus 1. We can take the analogy of array here. So SI plus 1 means 12H. The content of the memory location SI plus 1 is 12H. That will come to BL register. Now compare AL, BL. So these two registers are compared. So after the comparison operation, we can take proper decision. So as we have seen in the compare instruction, if both operands are equal, 0 flag is equal to 1. If source is greater than destination, carry flag will be set. If destination is greater than source, carry flag will be 0 or reset. So here AL and BL are the destination and source respectively. So here if AL is less than BL, then there will be carry. So JC next. So since we are sorting the array in the ascending order, there is no problem if AL is lesser than BL. Okay. So JC next. So the control will go to next. But here in our example, AL is 99 and BL is 12. So obviously the carry will not be set. So the control will reach here. So move DL comma SI plus 1. So to the DL register, SI plus 1 will be copied. The content of SI plus 1 will be copied. So DL will become 12H and exchange SI comma DL. So what will happen? DL and SI, the value at SI will be exchanged. So here 12H will be copied to SI. So this is the SI address SI. So 12H will be copied here, and next exchange SI plus 1 DL. So what is the value of DL? DL is 99 now, because this is exchange operation. So DL is 99. Move SI plus 1 DL. So what happens is, whatever be the value of DL, I will come to SI plus 1. So 99H will come to the second location. So 12H and 99H will be exchanged after this code. Now increment SI. So SI will now point to this location. Decrement CL. CL is decremented. CL will now become 5. Sorry, 3. CL value was 4, it will become 3. Now jump if not 0 to label 1. So jump if not 0. So decrement CL after this operation, definitely the answer is not 0. So again it will go to label 1, and the same procedure will be continued. So after one iteration, all these elements will be checked. The adjacent elements will be checked, and they will be exchanged if the left element is greater than the right element. So that is this iteration, and afterwards CH is decremented, and again this jump if not 0 label 2 is done, and again this iteration is done. So this particular program follows the logic of bubble sort, that is, adjacent two elements are compared, and if they are not in order, we will just swap them. So the same logic is followed in this program. So this is the 8086 program to sort a set of numbers in ascending order. Thank you. 8086 program to count the number of zeros and ones from a number. So here this is the data segment. There is a number DW, define word 5648H. So here let's look at the example. So here number, the value is 5648. So 5 is 0101, 6 is 0110, 4 is 0100, and 8 is 1000. So our question is to count the number of zeros and ones from a number. So here in this number, the number of zeros is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and number of ones 1, 2, 3, 4, 5, 6. So 6 ones and 10 zeros. So that should be our output. So for counting the zeros, we have declared a variable 0. For counting ones, a variable ones. This is a starting of code segment. Assume CS code DS data, the initialization of DS register. And afterwards we are loading the variable number to AX register. Move AX comma number. Now move BX comma 00H. Move CX comma 10H. These are the initializations. Move DX comma 00H. Now let's see the program. Up, rotate to left AX comma 1. So rotate left, this particular operation is used for rotating the AX register by 1 bit. So automatically the carry flag will be having the most significant bit of the AX register. So if carry is set, jump of carry will work, it will go to the label 1. So this is 1. So increment DX is done. So DX register is used for counting the number of ones. Next, increment BX is done. Now after increment DX, it will go to the next label, decrement CX. So CX will be decremented by 1, and jump if not 0 up. Again it will go here. Now rotate to the left, and the next value, next MSB will go to the carry flag. Jump if carry 1. So this will be done. If the carry flag is 0, this particular statement will not be executed, it will go here. Increment BX will be done. So BX is used for counting the zeros and DX is used for counting the ones. So this is how the counting is done. So after this CX register become 0, the control will be passed here. So CX register is used for holding the count of iterations. After each iteration, CX is decremented by 1 until it becomes 0. Afterwards, the iteration is stopped and the control will reach here. Move 0, BX. So whatever be the value of BX, that will be the count of zeros, and it will be in the 0 variable, and move ones, DX. So the count of ones will be in the ones variable, and afterwards the program is terminated. So this is a program for counting the number of zeros and ones from a given number. Thank you.